part B. At what wholesale price should the speakers be sold to maximize profit? Use the second derivative test to confirm that your answer yields a maximum profit. Okay, so we're trying to find the wholesale price. That means our answer is going to look something like P equals a number. $10 a speaker, $1 million a speaker. I don't know what it's going to be. And we're finding the P, the value for the price that maximizes our function, but we have a couple functions going on. Specifically, it's the profit function we want to focus on, which is why the profit function is written on my page, but for you, you have a bunch of other functions we just found. And we have to remember to use the second derivative test. If this were an exam, that would be worth, 20% of the question. Okay, first I need to find all of my critical values. So we begin by taking the derivative of the function we're studying. We're studying the profit function, and the derivative of, a negative 10p squared plus 1900p, well, minus the 48 will be 0, right? So we get negative 20p plus 1900. And to get a critical point, we set this equal to 0. Maybe you add the 20p to both sides so you don't have negative numbers. Maybe you subtracted the 1900 over, divide both sides by 20, and we get that p equals 95. So this is our stationary point. There are no singular points because we have no denominators, and we're ready for our next step. We're ready to use the second derivative test to see if a price of 95 actually is a maximum. Now you only have one price, so it seems like it's going to be the answer, but maybe it turns out that's actually a minimum and we'd have to say there is no maximum. The second derivative test has you find a second derivative. So I look over at my first derivative, and negative 20p plus 1900 has a derivative of just negative 20. The p turned to a 1, 1900 to a 0. Now the important part of the second derivative test is indicating what point you're testing. We're testing the only critical number, 95, that we have in our derivative. Except for when you go to plug 95 into negative 20, you just get negative 20. There is nowhere to plug p equals 95 into that function. But it doesn't matter. When we're using the second derivative test, we focus on the output, and we got a negative number. How we got it is not what's important right now. It's about evaluating the output. Negative numbers mean we're in a concave down region, so we've got that downward U shape, which means any critical value in a concave down region is a relative max. And because we were trying to maximize, and it's the second derivative test, it's verifying it's a maximum, we got what we wanted. Usually we check the endpoints next, but there are no endpoints on this function, so we don't need to make sure that an endpoint was actually a higher value than a price of 95. So we have our answer, $95 a speaker, right? What was the wholesale price that the speakers should be sold at? And the answer was 95.